It's not bad.
It's not bad. He says it's
No, it's not. I was gonna say it's not good, but then I don't know.
I feel like some people would like those.
Eating this.
It's like those yucky jelly beans that are like.
Bean Boozled, that is so much fun. I swear. I hate when it was pizza once.
Some people like them though. Alright, here we go.
Flavor change.
Eyes to the front. Okay. Yesterday, we got lots of formulas, right? You can go toss it if you want.
But it's a lollipop.
Well, I don't know what to tell you. Alright, here we go. How do we use these formulas? Now, quick heads up. Technically, we're going to be using them.
What a waste of 30 cents.
It's okay, I got it. So, coming back. We're going to really focus on this in Chapter 5, and we're in Chapter 4, so it's just an introduction. Okay, nothing to stress too much over. I'm not even really teaching you all the ins and outs about the proper way to prove, technically. You should probably say show. Just for sake of being mathematically correct. You guys just have a couple of these in homework, so I just want to give you two quick ideas or two quick examples about how to show, using your formulas, that this is true. Now, one quick thing you do have to know, even though we're going to go over it more in Chapter 5, one quick thing you do have to know is that you can only work with one side. You're going to be given an equation. They're telling you it's true, but you have to show why it's true. You're only allowed to work with one side, which means you're not allowed to move anything to the other side. You're not allowed to square both sides. You're not allowed to basically touch, even change in any way, shape, or form, even if mathematically it's legal. You're not allowed to do anything to the other side. You have to stick with one side. Now, technically in Chapter 5, we'll learn these are called T-proofs because we're going to write a T. It's not the same as geometry. We're not numbering it or using postulates or theorems or corollaries. But this is a way of keeping yourself to one side and one side alone. And my hint is to use the side with the most stuff on it. Like 1, well, 1 could come from 5 over 5. 1 could come from 100 minus 99. 1 could come from sine squared plus cosine squared. 1 could come from all sorts of different things. I don't want to play with 1. I want to play with tangent beta. Times cotangent beta. We realize it's not too left though. Okay, I want you guys to go ahead and look in. Yeah, you still got the lollipop. I want you guys to go ahead and look in your table of identities for what you could plug in, substitute for tangent, and for cotangent that may let it become 1.
1 over.
Bless you.
Okay, so coming back. Who got something? Who's tangent equal? 1 over cotangent. That would work. Sine over cosine. Which one did you choose?
Oh.
1 over.
1 over. Okay. Want to do that one? Oh, that was easy because
Sorry.
one fraction. Okay. Does this work? Yeah. Because what's 1 over cotangent times cotangent? What's 1 over anything times itself?
1.
Well, that's easy. Dun, dun, dun. If you want to be really snazzy and do an acronym of a Latin phrase meaning thus it has been proven, you can put QED.
What?
Something kind of like that. QED. Don't say quid. Because you're going to sound really dumb to anybody who knows math. Say QED instead.
Shouldn't there be a U?
Can I say
No.
in this class?
No. However, if you want to be super mathematical and not remember 3 random letters, you could put a box and just put a little shading. That's also mathematical. It just means thus it has been proven. Yeah, we got there. Okay. 51 is a little different. I mean, he's the same idea. We're only allowed to work with one side. I'm going to draw a T, even though I haven't taught you all the ins and outs of this. I'm going to draw a T just so that we remember to stay on one side. What do you guys think? Are we going to choose that one with stuff we can substitute, plug in, do math to, or that one where we have to make it all up on our own?
I think the one where we do substitute.
You want to make it up on your own? I think this thing. Okay. Now, in the first one, we really started with substituting. We did not start with math. We started with substituting, not math. Okay? We started with substituting, not math. But this one, we could start with substituting. But if you think about it, secant is 1 over cosine. Oh, this is going to get really ugly really fast with lots of fractions. So maybe we could do the math first. Wait, what math? Well, what's being shown here, guys? Binomial multiplication, and more specifically, difference of squares. Can I do math to trick things? Yeah. Secant theta times secant theta is, guess what? Secant theta squared?
No, secant
Careful.
squared theta.
You have to write little parentheses if you do it like that, and that's not pretty. There's a nicer notation that Ricky's trying to remind us of. We can put, and Caleb, secant, and Tyler, secant squared.
I did nothing.
Someone put it in the back. Was it Cameron?
Yeah, that was me.
See?
He was getting, he said, nah,
Yeah,
that's not the right way
I
to
said
put
it,
it.
I
He was
said
getting mad at me for saying it.
No,
Oh my
no,
god.
I said it.
I think it was Cameron.
Yeah, it was me.
Guys in class are a little competitive. What do you think?
Just a little bit. Just a little bit. Only when it comes to lollipops and Asians.
I could do outer and inner, negative secant tangent, positive secant tangent, but they're going to cancel anyway. So let's just do last. The positive times the negative is a negative. We go to Georgia Story anyway. So secant squared theta minus tangent squared theta is
Let's substitute.
Oh yeah, there's a
we could substitute, but isn't this a rearrangement of one of our properties? I swear we talked about it yesterday, didn't we? Secant squared minus tangent squared is 1. And if you don't like that 1, you could use the original, and you could plug in for secant squared, and you could say, well, he's 1 plus tangent squared minus tangent squared. Either way, whether you go straight to 1 because you know it's true, or whether you plug in and then get 1. Check QED.
Quit.
No.
Technically that
That
would
has been proven.
be Quit. That would be Ken.
Yeah, there's no
Plus
you.
it has been
Quit it.
quit.
It's silent. It's been quitted.
Alright. One more
was
thing.
implied.
In section 4.3, and remember we're supposed to start section 4.4. Come on, let's go. One more thing. Right triangle problems. Oh, come on, these are important. These show up all over the place. Geometry, algebra 2, now in pre-calc. We're not going to spend tons of time on them. We still have to talk about them. Whenever you see a right triangle problem, meaning whether it's being given to you in words, like some sort of application-y problem, whether there's some sort of picture with, like, I don't know, like a plane and ground and an observer, or like a ladder and a house, or like, what else do you guys get for these? Someone's shadow from a light pole, someone looking up at a monument, I don't know.
Lollipop.
Whatever would make a lollipop leaning against the wall, that's so weird. I was trying to make it work.
It happens.
Something with a right triangle.
Did you see a small
So it could be,
Sure.
it could be a word problem. It could just be they give you a triangle and they say, hey, guess what? You know this and this, but not that. Find it. Oh. You guys have seen these before. But if it is a word problem, 2 quick things to remember. Angle of elevation, remember? The rotation is going up. The rotation is going up. Now, in a word problem, it might not always be in standard form. It might not always be in standard form. For instance, you could have like an observer over here, and you could have some object up here. And then it could talk about the angle of elevation this way. And that's the exact same thing. Hold on. That's it. An object over here, there we go. An observer over here. And we could talk about that angle of elevation, which would be measured this way. Still an angle of elevation, still measuring up. This is where it goes a little weird. It's not just standard form. It's not like, I can't just say it's a positive angle, because positive angles always start from the positive x-axis. But I could say it's a rotation up. That's an angle of elevation. Whereas depression is a rotation down from a higher object to a lower object.
Hot balloon. What? Hot air balloon.
Yeah, it could be. You could either be someone on the ground looking at the people having fun in a hot air balloon and the angle of elevation up, or they could be in. Now this gets a little tricky. But If you're talking about the people in the balloon, the hot air balloon.
Hot air.
Hot air balloon.
Hot balloon.
Okay, we got this. People in the hot air balloon looking down at someone on the ground. That could be an angle of depression. But here's the tricky thing.
Oh, how?
You wouldn't know this and what it is. You're like, wait, it's just the balloon and this person. Why is there an angle?
Hot air balloon.
No more sugar ever again. Okay, so come back. This is weird. Listen, this would be his line of sight or her line of sight, whoever's in the hot air balloon looking down. Okay? So this is line of sight. It's not an actual object. Sometimes you're measuring from something that, in a sense, is invisible. Because if someone's in the hot air balloon, they're looking out, that would be their line of sight. And then if their angle of depression looking down, there is an angle there, and we can make a right triangle out of it. It's just not of an actual object like a ground or a pole or a house or a ladder, etc. Anyway, something to keep in mind. Oh, sorry. Some of you are still writing. Couple more seconds. All right, so we have 2 more examples, and then we're done with 4-3 finally.
Woohoo!
One is going to be just a triangle, no words. Stuff's missing, stuff's there. Figure out what's missing.
I like that. Oh my.
Me too. Like in geometry, my favorite ones were where you had all these different parallel and intersecting lines. You had to figure out like all the different things.
Yeah, not that.
Those weren't that bad.
I thought they were fun. They're little
They
puzzles.
make you sad.
Okay, fine. Those of you that are sad inside when you see those, never mind.
Tyler's sad inside.
We're gonna see one where we just have missing stuff and present stuff, and we're gonna have one word problem. Okay, here we go.
You're sad inside anyway.
Question.
You're sad inside anyway.
Write it down. Triangle. No words. Don't have to stress about a word problem. Write down the triangle. 60 degrees. Let me label it real quick. The little angle mark. 10. And a lot of you guys would be like, oh, sweet, Pythagorean theorem. Like what? X squared plus y squared is 18 squared. Solve. Except. It's a great formula. Very useful formula. Very important formula. Even gives us our easiest trig identity. Sine squared theta plus cosine squared theta is 1. But too many variables. So I must need to use my other clue. And my other clue I have an angle. And I have a 60-degree angle. And that 60-degree angle is going to have a y which can be relabeled as, everybody, opposite. Come on, everybody chime in now. Who's this guy going to be?
Adjacent.
Adjacent. Ricky was loud, but they're still loud and not talking. Who's this going to be? That's a little better. So, why not use tangent? Yeah, we want to get that 18 in there, right? Because we want the 18 in there, we want the 60 in there, and hopefully only one other variable so we can solve. So give me a trig function that's going to use 18 and only one other variable. Sine sounds good. Help me fill in. Sine of 60 equals who? SOHCAHTOA. Y, opposite, over hypotenuse 18. Oh, hey, guys, can't we just solve for y by multiplying both sides by 18?
Mm-hmm.
Well, that's cool.
Stick it to the man.
Not quite. Stick it to the man's when you don't have to simplify.
Oh, stick it to the man.
Except. Oh, wait, no calculators. Hold on. Who is that?
Oh.
That's 60. 60 is a pi over 3, and pi over 3 has what as an up a lot? Square root of 3 over 2.
But.
Nope. No buts.
However.
Because. Thank you for the synonym. That doesn't really change much. Okay, so. I have an exact answer. You would have a rounded decimal. I don't want a rounded decimal. Now, sometimes, if it was like 57 degrees, yes, by all means, get your calculator and make sure you're in what mode?
Radians.
Not for this one.
Degrees.
You need degrees, right? What's a degree?
But we're
57 degrees?
unit circle.
Yeah, but if they're giving you degrees, why not just use degree mode? Awesome. Wait, quiz like tomorrow, unit circle quiz?
No, like the
Oh, got it. Yes. Because of word problems, there will be a calculator part, but because of unit circle, there will be a non-calculator part. So like that. Which you guys, I think, went faster on last time, but maybe we need to slow down a little bit in the sense of not making as many mistakes.
Wait,
Or
what
just
was the
study a lot
class
harder.
action?
So here we go. Let's keep going. We have y. Could we plug this into the Pythagorean theorem?
I guess.
I guess. Or we could just say, why not use cosine?
True.
Because cosine is going to be x over 18. We just saw how, hopefully, somewhat easy that was to solve. Multiply 18 to the other side. Ask ourselves, wait a minute, 60 degrees. Whose cosine? Over a little? 1/2.
Oh, that's 9. Yeah, sure, you can tell.
You too.
It's just, and I didn't even have.
So how do we do the word problem?
Oh no.
Wait, can you go back?
Oh, it's 9. Does that help?
The Washington one. So bored.
You're boring.
So about making this a safe environment. Okay.
That was gone on like the third day of school.
Second base.
We're all
Who's first?
Okay, word problems. Remember, you don't have to write them word for word, but you do need to give me the most important information. Like, Washington Monument. Period. There you go. That's the context. And then give me a good picture, which, oh my goodness, look at them just making it easy for you. They give you the triangle. Now some of you are like, so are we assuming that the person is looking from their feet? Okay, we're just going to make the person a dot. We're going to make the monument a line.
Make it a spider.
And then we're going to connect. Okay. Stop worrying about centers of gravity and this, that, and the other. That would be if we're in physics and we're not. We can label it with 115. We can label this with, hey, why did I say just a second ago sometimes it's okay to use your calculator? I'm not doing unit circle on 78.3. That's not in the unit circle.
Well,
78's not.
it's in the unit circle.
Okay. It is. It's not in those values I make you memorize.
Okay.
Unless you want me to start making you memorize.
No, we're good.
15.
And then why? We could approximate.
78.3.
We need to use who or what? Pythagorean. No. No. I'm not even looking at the distance from the person to the Washington Monument.
Cosine.
Cosine. Why? I have an angle. If we were to label our sides, who would this be to 78.3? Adjacent. And who would this be? Wait a minute. We're already using cosine.
Yeah, tangent.
Right? You gotta think about it carefully. If we're gonna do, guys, let's focus. If we're gonna do opposite over adjacent, what trig function do we use? Yeah, so could TOLA, right? We use tangent. Now, once again, I just said a second ago that we need to be in degree modes if the angles are in degrees, unless you want to convert to radians, but it takes extra time, right? We're allowed to use our calculators, use it well. Multiply 115 to the other side. Don't need to do degrees, minutes, seconds. It's a nice decimal. We just have to plug in. Negative. Uh-oh.
Oh, what?
555.314.
How'd you get that?
I don't know, probably that wrong.
I think that's right, but make sure you're in degree mode. No, that sounds good. 'Cause I think posted online, if you were to search for the height of the Washington Monument, I think it's
Yeah, I was in degree
555.
mode.
Might be 554, but it's one of them. It's really good.
Kids.
Do you have they back them up? Do we agree?
Yeah.
Okay.
He's right.
And then I think it's in feet. Okay. Guys, nicely done. 4.3 we got through, and now we need to do just like we were saying yesterday. We need to start 4.4. Oh, come on, it's even.
Unit circle quiz tomorrow.
Unit circle quiz tomorrow. Now, guys, if you look on the backboard, 4.4 is not due tomorrow. We are starting it today. But the only things due tomorrow is 4.3 and a mastery of your unit circle. Doesn't mean you have to be able to do the speed problems. But you do need to be able to work it out and get those correct answers. I know a lot of you guys have older siblings that have been through and done unit circle and done well. Friends who maybe are in higher math that have done well. You just friends that are in honors and they've already been through it and studied it and had to work on it. You can also study with each other. However, unit circle. Focus, guys. Unit circle is kind of like a rite of passage in the sense of getting it down for yourself and hopefully keeping it down. So please don't blow it off. I know a lot of you guys were a bit discouraged after that last test. I needed 2 people to finish taking it yesterday. And actually they did finish. Ooh, by the way, hold on, look at the camera. Have it in the corner, you leave it on my desk. Sorry, I forgot. Calculus got theirs back yesterday. You guys are gonna get it back today.
We're getting today?
But listen. Listen. Some of you, this was your highest test, or at least it was one of your higher ones. Some of you, it went the other direction. Some of you are just pretty consistent and you stay the same-ish. I'm going to pass out correction papers first.
Wait, is it for a group or the
For just pass back. But guys, hold on. If you don't like what you're about to see, shouldn't that, please, give you more motivation to ace like the unit circle quiz tomorrow with a bonus opportunity? Or the test on Friday that's just on 4-1 to 4-4, which is basically right triangles? So cow and the unit circle? Come on. Even the giraffe doesn't say it.
There's a giraffe in the back of the room.
You're a giraffe.
I am.
I know, it's right there.
Well, not sure he wants to now. I'm not sure if it's
But
always.
this is you. That's
Delmo.
This is you. Bad, bro.
Delmo?
What is it?
Giraffe is named after Miss Delmo.
Oh, what was the check?
Alright, hold on. I have this ready, but we're gonna need a little bit into 4-4, because that's what we need. This is what we need to finish tomorrow after the use of this. So focus on it. Okay. Don't we know that sine is opposite over hypotenuse? I know some of you just put O over H, and that's perfectly fine. I don't put O because I don't want people to think it's 0. That's the reason why. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. But here's the problem. Literally. Here's the problem. And they tell us, let negative 3, 4 be a point on the terminal side of theta. Find the sine cosine. Find the sine cosine tangent of theta. But guys, where's your right triangle? He's not there. But we have to make him. What's the one piece that we can grab?
3, 4. Negative 3.
Negative 3, 4. Well, how on earth is this a triangle?
Draw down.
Any angle is measured with the vertex, right? Often vertex and Jason too. It's measured in normal standard position. And with that, now hold on, this is something that we have to remember, and hopefully the unit circle helps. Which way do we draw our triangles? Down or across?
Down.
Down. Every time we have to go down. This is our triangle. I know that our angle is technically outside. This is theta, but for that outside angle, guess where we're going to look? Inside the triangle for our trig. Now we have to label our sides though, or else we can't do all of our different ratios. So to this one, here's our adjacent, here's our hypotenuse, and here's our opposite. The question, what are the numbers that go along with this? This one is 4 because the y was 4, right? Okay. What's this one going to be?
Negative 3.
It's 3, but since we're in a Cartesian coordinate system, we're going to use the negative. So
5.
negative 3. And some of you are like, wait a minute, it's a 3, 4, who? But if you didn't know that, couldn't you do side squared plus side squared equals hypotenuse squared and solve that? I don't know, because I'm silly and I labeled it wrong. Just too focused on making sure to write OPP instead of just OP. There we go. So then, kiddos, fill in your triangle. Or fill in, I should say, your triangle is filled in. Fill in your trig ratios. What would they be? Whose sign?
4 over 5.
Opposite over hypotenuse, so Catilla, 4 over 5. So as you notice, 4, 4 isn't going to be tons different. There's just going to be some new things to look at and some new types of problems that are coming our way. Cosine is going to be, and then tangent's going to be. Now technically it's 4 over negative 3. However, a positive over a negative makes everybody negative. So in essence, it's just kind of like making the whole fraction a negative. Because a fraction is like a decimal that's negative, it's just negative. You don't only think about numerators and denominators. Now you guys, as I pass out, I'm going to go ahead and have you, ooh, that might be helpful for tomorrow. Nice thing is we've already talked about it, but maybe some of you need to have it written down. You guys go ahead and write this down as I pass out the test in literally no particular order. If I thought about it, I might have pulled A's to the top or over hundreds to the top so that you guys could know who to go to get help from.
Wait, hundreds at the top?
I would have, but I didn't. I just happened in no particular order. And then you hear your name, come on down. David, Maddie, Fuller, sorry. Jason, Nathan, Mia.
Same.
Jacob, Naomi, Maddie, Emily, Ricky, Austin, Jesse, Cameron, Alex.
Oh no, wait.
Consistency.
And
Consistency is, you should be 120% by now.
It's just barely.
Nadia, Elaine,